Is that? Yeah.
Yeah.
Yeah. Okay. Good. So thank you for coming, and again, I hope you are awake. And I mean, this session really, I think the name is requirements traceability. We definitely cover the traceability as part of the session, but I think it's even more. It's actually here we are presenting the work that we've been doing in the last 6 months, I think.
A little over.
Yeah, a little over than 6 months. And the goal is to, to define low-level requirements for the Linux kernel. And yeah, so let's get started. And actually, this is a work that was started by Chuck Wolber, that is online, I think. I saw him online.
Hey, Chuck.
Hi, Chuck. And,
Hey guys.
and Kate and myself. Yeah.
And the architecture team participants.
And the architecture team participants. That's right. So therefore, if you are interested in this topic, please join the safety architecture working group. Okay. First of all, some terminology. So what is a bug? It is a violation of expectations. A requirement is a developer statement of testable intent or testable expectation. And by testable, we mean it must be provable. The requirement should be defined in a positive format. The software shall do something, whereas something that is untestable is something that is unprovable or not reasonably provable, like shall not. And design is a decomposition of intent into pass-fail testable form. And the decomposition is, breaking down big ideas into smaller ideas. And this session is focused on low-level requirements. So requirements that are defined at functional level, really. Because, and following here the DO 178C, so the avionics standard definition, low-level requirements are software requirements from which source code can be directly implemented without further information. Okay. Okay, now we have clarified the terminology here. And now let's look at the validation versus verification principle. And validation is making sure you do the right thing, whereas verification is making sure you do the thing right. And author is unknown, and if there is an unknown author for this, you can blame Chuck because he did it. And so basically, a verification bug is where the code is violating the documented expectation. Okay, so the code is not doing what it is expected to do. Whereas a validation bug is that the expectation is wrong. For example, if there is a bug in the way the requirement has been created, for example, may not trace to a maintainer signed off on the requirement patch. So maybe if we create a requirements without the maintainer approval, that will be a sort of validation bug.
Would you consider a validation bug if your set of expectations was incomplete?
Yeah, that would generally be a version of a. You just don't have enough information. Yeah.
If you do it purposely, yes, indeed. What may happen is that you put together requirements, you push it upstream, and then when you write a test that you may trace using Bazel, for example, you figure out that your requirements is incomplete because you may have missed some parts of the code.
It did something bad, but you didn't have an expectation about that.
Exactly.
You knew it was bad, but nothing told you it wasn't the expectation.
Exactly. So it's a kind of gray area, an incomplete bug, an incomplete requirement.
Yeah.
So you consider that one a validation bug, right?
It can be both. Like,
Okay.
it can be both.
It may know it may may not be a bug either. I mean,
Exactly,
it
yeah.
would be picture.
Okay, now, I think if we, you know,
Okay.
let's move on, because I think we will spend a lot of time talking about validation versus verification.
Yeah,
And let's look at the more concrete stuff, right? So bug-free code principle. Indeed, we need to document the testable expectation. We need to document what the code is expected to do. And we need to trace this testable expectation to developer intent. So basically, we need to have a maintainer signed off, for example, on the requirements patch. Okay. And indeed, after that, we need to develop pass-fail test and and validate testing with code coverage. In general, I would say that we need to put together verification evidences to verify the requirement. Okay, one evidence is the test. There are also other evidence like the Git code review in the mailing list, for example. Right. Now, this initiative is exclusively focused on point number 1 and number 2. Point number 3 is crazy important, but we cannot solve all the problems, in a single activity. So this is something that will take care, later or in
or
parallel.
actually, there's things that are going on between Boeing and the university for code coverage, and
Yeah.
there's also aspects of code coverage going on in kernel CI. So
Exactly.
hope to pull some of these things
So,
together.
yeah.
And connect this all eventually.
Yeah, exactly. So
Mhm.
later we'll pull everything together, but this specific, activity is focused on point number 1 and number 2.
It's also probably worth mentioning that, without any documented design or traceable design, I think literally all of the kernel testing right now is, unless the maintainer themselves wrote it or signed off on it, it's a best guess, a good guess, educated guess, but it's still a best guess without confirmation.
Yes, it's something that will be hard to independently assess in terms of, is it really sufficient, complete? Who knows? Right, past events. We started at 2024 Plumbers Conference in Vienna, where I presented the work that the Safety Architecture Working Group did with respect to documenting the kernel source code that quickly translated into it translated into an activity to define requirements for the Linux kernel. We put together a requirements template draft that I will present later in this deck. And and this draft was presented at the workshop at NESA in 2024, where we had Stephen Rosted attending such a workshop. Stephen Rosted is a well-known kernel maintainer, and he kindly volunteered to expose his tracing subsystem to this experiment. So effectively, we have him on board. And in fact, we are now using the tracing subsystem as our guinea pig, if you like. And I will also, as part of this deck, I will show you the initial requirements definition that we did for some functions of the tracing subsystem. And and last but not least, we did these initial pilots that I will present today. And we received significant feedback on this. And we have defined the short-term directions that I will also present today. Okay. And now we are here at Lund.
And we will be trying to get into plumbers again. From
Yes.
December,
Yes.
and you'll probably see some of this work probably in Europe again in the fall.
Yes. Yes. We'll talk about this in the next steps, the very last lab.
Okay.
Okay. So what are the requirements for the requirements templates? So we should avoid substantive changes to the current Linux kernel development process. So The requirements template that must be compatible with the current kernel development process. Each requirement shall have a stable ID and unique ID, and it shall have an hash key, and basically both the IDs and hash keys shall be globally unique. Following like an SHA 256 algorithm for the generation. And they shall be generated without central coordination. They shall be reproducible, and the requirements template shall be embedded in the code. So this was requested directly by Thomas Glexner, if I remember correctly, at the
And other maintainers.
other
There was
maintainers.
another maintainer
Yeah,
that wanted
they
to.
They said we want the requirement expectations to be directly embedded in the code, because
Keep them
otherwise.
as close to the code as possible.
Yeah, otherwise they will not be maintained. And the template format should be machine readable, because there must be an automation around it. And should be compact and succinct to avoid unnecessary clutter, should be easy to read and biased against complex formatting. Should be standardized. We are using SPDX, so this is also very important, so that it can be used also in other OSS projects, and we should enable detection. Basically, we should support an efficient change management. So when there is a change in the code or in the requirement, there shall be flags that are raised to make sure that such a change doesn't go undetected. And indeed, since you are supporting SPDX, we also we must be referenced by other systems. Okay, but in general, many of these are kind of good requirements, principles, to be honest. And let's look in practice at the table of our template. We have different fields. The first one is the requirement ID. It is our unique requirement identifier. There is an end field that marks the end of a requirement. And
Guys, sorry I have to interrupt. Nico called. Does anybody here have a white C40 car?
huh?
A Volvo car in the parking lot?
No.
Nobody here has it, right? The police is there and watching it very carefully, so in the parking lot, Nico was there, so. It's none of your cars here, you don't drive cars.
No, I didn't.
Yeah.
Like that.
They might take the car.
Okay.
Continue, sorry for you.
Okay, we are safe from the police, and so let's continue. So the requirement reference, so that is a field in case we need to cross-reference code that contribute, to that requirement or to another requirement. And we have SPDX requirement hash key, that is the modification sentinel. So this is the hash that is automatically generated as the requirement evolves or the code changes. That will.
Yeah, no, it's okay.
Yeah.
That's odd.
So yeah, so this is basically the field that changes, and that will trigger the maintainer attention in case there is code or requirement that has changed. We have a requirement child item that would point to a decomposed requirement. An SPDX requirements subsystem. Basically, this is the identifier of the subsystem or driver that the requirements belong to. The SPDX requirement text. This is where we are defining the requirement. So SPDX requirement text is basically where we are saying the code is expected to do X, Y, Z. Okay, so it's basically where all the semantics is contained. And finally, we have an SPDX requirement note that is just, is a clarifying note if needed. If there is, any information that must be added to disambiguate the requirement. An important thing is that you can see that there is a location here that is inline versus sidecar. So whatever you see inline, it means that that field must be embedded in the code. And sidecar means that instead, that field can be moved into a separate sidecar file.
So this isn't intended to be part of the code, not
So
alongside the code.
part of the fields that are marked inline are expected to be in the code. And they're expected to be minimal, but you should be able to derive the rest of it from those two.
Doesn't, okay, so I guess I.
That's why you basically have to, you start with an ID
Yeah.
and you'd have your end,
Yeah,
and any of the code in between would be considered the requirement text, and then there'd be the hash.
so this is, okay, so this is. Includes it's very much purely about low level requirements.
This is purely low level requirements
So
that we
it's
eventually.
in the specifically.
We need to-
perform- Yeah,
To Igor's point, we need to basically get the basics right at the starting point, so we can build ourselves up over time to be more authoritative, especially in the key areas of the kernel. So this is a way of starting to look at, okay, as we work with the work from Alessandro and understand what are the key parts. This gives us a way of focusing on, as we do the analysis, we can get the upstream maintainers to sign off that, yes, what we think is happening is a requirement here, it really is. And then we can start to track it in the code base as well as with sidecar information.
Exactly. Okay, so I will not spend much time on this. So this is the line format. It complies with SPDX, REC, and it is maximum 80 line character like standard Linux code, full character with UTF-8. So I don't want to spend time here.
Yeah.
You can look at this offline.
We took the pattern that's been used for licensing in the kernel already.
Yeah.
So the kernel community is used to seeing these SPDX identifiers in for kernel licensing. So we're just adding another set of type of comments elsewhere that can be machine readable.
So the formatting is the standard one that already exists. And now SPDX requirement ID, it is generating using an SHA 256 algorithm. And in order to generate that, we use 4 different fields. The project is the name of the project, Linux in our case. The file path is the path where the code resides. The instance is the requirements template instance. So it is actually the whole requirement text, and the code is the code that is just underneath the requirement instance. So you will look at examples later. You will see that we are following the logic used by kernel doc headers, where basically requirements appear as comments that are just sits on top of the code. Okay, and this is for the main reason is maintainability with respect to the current Linux kernel development workflow. So the hash key. So the hash key is using the same field as the SPDX requirement ID. The very first time the hash key is generated is exactly the same as the SPDX requirement ID. So the first time you create a requirement, hash key and the requirement ID are exactly the same. What happens is that as the code evolves, or if there is any modification to any of these fields, the SPDX requirement ID stays the same, whereas the hash key changes. And every time the hash key changes, that will trigger the attention of the maintainer, like, oh, something has changed. You have changed the project. I hope not, that is very unlikely. But maybe, a file could have moved,
And inside the SPDX graph, knowledge graph that's there, we can put the linkage and say, this requirement has been derived or has been updated. We can basically, as we mint these objects, we should be able to reflect as things have changed, to be able to track that as well, which is going to be important for some cases in fields.
Exactly. Okay, so this is the ASCII child is to trace and decompose the requirements. So much to say about that. So it links to an SPDX requirement ID of decompose the requirement. Sys basically it will be the subsystem that map to that specific requirement. Text is the requirement semantic, so it must be human readable, and it complies with the requirement definition best practices, and it must be detailed enough to allow implementation without additional information. And we'll look at specific examples in a bit. So the requirement note is an optional note. So as of today, we have not experienced any, we never had to write specific notes, to be honest. But it can be, maybe in future, let's see. Okay, so if there are no questions about the template and the formal aspects, let's move into the semantic aspects. Okay, good. So the semantic aspect is what do we write under SPDX requirement text? Okay, so it's like, okay, now we have the template, but then, how do we write requirements in practice? And indeed, we need, from a semantic point of view, it is important that we document the intended or expected behavior in consideration of different design aspects impacting such behavior. And indeed, it must be described in a way that makes it possible to define test cases. If I write a requirement that is untestable, is useless, right? And or it's not very useful. In order to write testable requirements, we need to document the design elements that are impacting the expected behavior, and also the design elements that are impacted by the expected behavior, because otherwise you cannot define the pass-fail criteria for your test, and you will not know, where to look at, what to trigger, right? And how we do that? Are you familiar with the kernel doc comments? Anybody that is familiar or not familiar? Have you ever heard of kernel doc headers? Kernel doc headers. In the Linux kernel? No? Yes, no? You're familiar with that. Yeah. Okay, so, well, kernel doc comments is kernel doc headers is already a standardized way to document the behavior, to some extent, the behavior of the Linux kernel functions. Okay, it is mainly focused on the function templates and on explaining the input parameters and the return value. And what we did is here, what we are trying to do, we are extending the kernel doc headers and the guidelines for writing kernel doc headers, so that we can also write testable requirements. So, and to this extent, what are the elements that are impacting the expected behavior? We have the input parameters, the state variables, we have the software dependencies, and we have also the hardware dependencies, the firmware dependencies, and we have.
Sorry. This slide shot. All right, super clever. I'm not.
No? No.
Come back.
It'll come back.
There we go.
Eh,
What was the idea of fast charging? And
yeah, so, yeah, we have the firmware dependencies. Like, you know, device tree blob, the CPI tables for runtime services. And we also have compile time configuration parameters, and we have the runtime configuration parameters, like that are calibration parameters, okay? All of these elements can impact the expected behavior of a function. So we need to, when writing requirements, we need to document, you know, the relevant ones, okay? And also we need to document the behavior of the design elements. So we need also to document the design elements impacted by the expected behavior, like the return values, the input pointers, the state variables, and the hardware design elements, like hardware registers. So all of these elements can be impacted by functions that we are documenting, right? So you need to document what are your possible return values. If you're passing an input pointer, you know, what is going to store, what is it pointing to after you run the function, how this function has changed, you know, the states variable, and basically what is there any effect on the hardware, right?
Where are the design elements? Why? How do you identify the design elements?
How do you identify
By reading
the code?
Yeah,
By reading the code.
So
The
what,
bit-
so can you give me an example of a design element?
Like for example, when we looked at the trace, I will show you an example
Okay.
later.
Yeah.
So. And yeah. So indeed, so some consideration. So when we write the requirements, we need to consider testability. Okay. So and yeah, so basically to this extent, you know, we need to, it is important, you know, to document allowed or not allowed ranges of values, equivalence classes, corner cases, error condition. So that it is possible, you know, to write a meaningful test plan. We need to consider the scalability, okay? And indeed, you know, the expected behavior shall be limited, you know, to the scope of the code under analysis. And any dependencies should be described, you know, in terms of possible impact on the invoking code, deferring, you know, the details with respect to the documentation of this. So it is not possible to document everything in the top level function, basically. And also we need to consider the, you know, the feasibility, because only meaningful and useful expected behavior shall be documented. There is a function invoking print key, not going to document, you know, the print key in the requirement if it does not contribute, you know, to the expected functionality. You know, it's something is there as part of the implementation, but you know, we cannot, otherwise we end up writing a pseudocode, and we did that actually when we start. And actually, with respect to the feasibility, it is really important to have the Linux experts involved, because otherwise, you know, we need to find the right level of detail. If we start writing pseudocode, it's completely useless. Or, I mean, it could be useful, but it's not maintainable, and you end up with the same level of complexity as the code. So, what for? So, what have we done? There is a branch here that we created to start writing a requirement. As already mentioned, these requirements are written for the tracing subsystem. Okay. And here you have an example of some of these requirements. So I can just click on this, for example, internet. Okay.
And just to make clear, that's not the ELISA out of tree branch. It's just like The clone repo for,
Yeah,
This is a
Working on
clone,
it.
this is a clone repo from Linux. Yes,
yeah,
yeah, of course.
it's not our branch for,
Yeah, so I don't know if it is readable.
no.
up at the size a little bit more. There we go.
Okay.
It's visible now.
No, it's readable.
Mhm.
So this is an example of, so how did we start? Okay, so we said, okay, you know, like Stephen Rosted, he kindly, you know, volunteered to, you know, to work with us. Let's start from the tracing subsystem. We started from a couple of functions that are defined as exported symbol. The reason why we started from exported symbol is because if you look today at the kernel doc header documentation, it is written that exported symbols at least should be documented. Many of them are not, actually most of them are not, but theoretically, you know, these are you know, recognized as important interfaces to be documented. So we said, okay, let's start from here. Okay. And so this is the function, like trace array set clear event. And you can see here there is an SPDX requirement ID. There is a to do here on purpose. There is a tool that Alessandro developed to automatically fill the SPDX requirement ID, because this cannot be filled manually. Okay. And then we have the text. So the text is the requirement description. So you can see that here we have the function, the name of the function. We have a short summary, enable or disable an event within a system for a trace array. TR is the input trace array. System is the system name. Event is event name, and enable is a flag saying, you know, true. If it's a boolean, basically, to you set it to true to enable and to false to disable. Okay. And this is a summary. Here there is a short summary. This is a way for other parts of the kernel to enable or disable event recording. And here we have like the formal expectation. That is, this function shall properly unlock the global event mutex. And this is an example of software resource, like a relevant software resource. You asked, you know, how do you identify that? By looking at the code, we identified this one, for example. Okay.
I think it was a bit of confusing because you called it a design element.
I called it a design element because if I say a variable will not be enough, you could also have like a pointer, a global pointer, right? So
Yeah, understood.
see what I
So
mean? Like,
the bit that confused me was that you also mentioned that if it was referencing a design element like hardware resource, such as a register, that you want to include that. So I wondered how you identified those.
Also by reading the code, sometimes you have a pointer that directly map to hardware registers, right? And these are passed by device tree or by a CPI table usually, and there are global structures that are filled, that are read.
Populated, yeah.
So
in all cases, you're referring to something which is either a variable, a local variable, or a global variable,
A parsable token of some sort in some ways.
or a macro. Or,
Yeah,
Yeah.
macros, I think, are the good part.
Yeah.
So this function shall probably unlock the global event mutex before, after invoking ftrace set clear event unlock. That is another function passing along the same input parameters. Okay, and then we have the specification of the return values: 0 on success, and if the input TR is null, inval if the parameters do not match any registered events, any other conditions returned by this function. Okay, so and yeah, so this is an example, and I think the most interesting one is really, so basically these are sorry. So basically, A, B, C, D are all functions that are part of the same code tree, and they end up in the real function that actually disable the event, that is this one. And if you look at the function, it is complicated. Actually, even Steven admitted that it is, complicated. And basically what we did is we struggled a lot with this function, really. Initially, I wrote pseudocode because in the process of understanding what it does, the first thing you do is you write pseudocode, and then through different iteration at the end, we came up with a set of multiple expectations. So effectively, you can think of multiple requirements being allocated to a single function, right? Practically speaking. So now, as of now, we have not yet broken down. So formally here, we still have a single requirement. It's not been broken down into multiple requirements yet because at the moment we are still focusing on the semantic aspects first, and later we will polish it and break it down into I mean, it's at the end of the day, practically speaking, it's easy to break it down into formal into multiple requirements. The difficult part is really to write these all different expectations one by one. Okay. So, and now for example, here, function expectation. If soft disable is 1, a reference counter associated with the trace event shall be increased or decreased. So reference counter, so this is yet another software resource, or decrease according to the enable parameter, being 1 enable or 0 disable respectively. If the reference counter is bigger than 0 before the increase or after the decrease, no other action shall be taken. Okay, so this is a testable requirement, right? So it says, you can pass fail criteria can be monitored by looking at the reference counter value, right? And also you can check that if the reference counter is higher than 0, the function returns right away. Okay. And basically, and following this fashion, now I don't have time to explain, in detail what this function does. But this is just to show you that, here, what we are doing, the idea here is to write human readable expectation, and you can really.
Or testable expectation.
And testable expectation. Yeah. And here, without reading the code, you can read here, and the goal here is that you can have an understanding of what the code is expected to do. Okay. And this is embedded in the code, will be maintained in the code, and I hope that soon we can, start pushing initial requirements, to the tracing subsystem.
Yeah, so the view is to initially push these as documentation.
Yes.
Without the SPDX tags.
Yes.
Into the functions. And then see if we're hitting roughly the level of testability people want, and then we can add the tagging later.
Yes.
That was the path that Stephen recommended us to go forward with.
Exactly.
And I think if you go back to the other slide, you've got a key point here, Gab, which is by doing this exercise, we found a bug and got it fixed.
Yes. Yeah.
And I think as we do more of this for the kernel, we will increase the quality of the kernel and increase the maintainability and sustainability of the kernel. So that is part of the argumentation we will be using with the maintainers.
Yeah. So basically, this is the bug that was found, and basically, when this function was invoking the callback to a registered event, it was not checking the return value. So it was always succeeding, even if the callback was failing. And yeah, this is the fix, easy peasy. And just a very simple patch. But just to show that this is not like an exercise that is, it's not just a documentation exercise. It's an exercise that
Will
would
hopefully
lead,
improve the quality.
yeah, actually, if you want, I can show you something else.
Yeah, but things like that really also show that working with the code as a starting point still has value. Because often people see this as a kind of re-engineering measure that is just work. And actually, you should have had the requirement before and then written the code,
No.
because that's the only way to add value. But here you see, hey, I had code and I was then thinking about, is this really what I want, and describing it and finding something.
Yeah.
Wow.
So, absolutely, but so the bit that I'm finding
You're having a.
hard to digest here, and actually, what you've done is absolutely in line with what your stated intent was, which your description of a requirement is a description from which I could recreate the code.
Right.
And
And
my
create
question
tests.
is that what we want?
You can
Is
then
that
write the
what
code in
is-
Rust.
You want.
Yeah, you could rewrite the code in Rust, yeah, absolutely.
This was also a question that I made to myself, I put to myself. In fact, when we had the session with Steven Ross, we came up with two proposals for requirement. One that was a kind of simpler, that was containing less detail compared to what you have seen. And another one that was more verbose. And Steven said like, no. I want, I like this one, I want this one, I want, like all the testable expectation one by one. And this is the reason why we say, okay, like, I follow, like, you decide, I follow, and, now we are going for this. But something else I want to show you is that when I analyzed that complex function, basically I realized that it's really complex, and actually there are some parameters that are redundant, and here there is a patch that I wrote to basically to simplify the function and basically the flags that can be changed. There is a soft mode flag and there is a soft disable bit flag, and they are kind of redundant together. So this patch actually improves, the simplicity of the code, and it leads to basically, it also fix a bug in the code, because there is also another bug that you will see in the mailing list in the future.
Uh-huh.
And so, but just saying that it's not just a documentation exercise. It's something that really
Yeah.
helps to improve the integrity or the trustability.
Well, it improves the quality, but it also improves the sustainability of the kernel over time for the parts that it's worth doing the exercise. So if people start to do these exercises and get the maintainers to accept these patches, because it won't be the maintainers creating these patches. We know that right now, but they can tell us, yes, what you're proposing does match what I expected the code to do.
So you're showing how to do this in a way that adds value that the maintainers recognize and accept, and actually demonstrates.
This is the whole social plan here. Because we know that they won't ever add, or they would have done it already.
I'm just anticipating the reaction that to essentially what you're doing is translating the code into English.
Yeah,
And yes, I can see value in that, but my first thought is, this is great, you do this, you translate the code, then the code changes. How do you ensure that the code and the English description
The hash key.
continue to actually,
The hash key.
the hash key.
no, so, yeah. Yes, so you're saying is that the hash tells you that there is now a delta.
Yes,
Yes,
there is a delta.
So
Somebody
and
else
now you're
so we can make it
maintaining,
checkable
now you're maintaining the code and the English description in
Yeah.
parallel.
Yes.
in parallel, exactly, and
Yes.
maintaining enough of a
So you're-
linkage that we can
Okay.
reason about it when it's in the knowledge graphs.
I mean, the thing is, when you do a change, the hash changes, and the one submitting it is there to
That's
also
quick.
update the documentation.
Did you already discuss about a way to integrate this that doesn't interfere much with bisection? Because typically one problem that there is.
My section ignores comments.
No, but if you make it, so if you have a patch which is purely comment, it will be ignored.
Generally, yeah, mostly, most of the stuff, Git bisect tends to work on executable code when it's running. Was my understanding, but please tell me if I'm wrong.
I don't know, I mean, I've always used it on regular patches where usually you have code, but I was wondering.
Yeah,
Because usually
we-
if you have cosmetic patches, they tend to not like.
yeah, like I say, with the Cregit work, for instance, when we're doing the Cregit analysis, it's only working on the code itself. It ignores comments. So that's one of the limitations on Cregit, quite frankly, is we don't parse the comments. And generally, bisect never uses the comments. Is my understanding, but someone correct me if I'm wrong.
I don't know, I don't think. I don't think
No, you're not
there is-
wrong. You're right, Kate.
Mhm. So this gives us a way to not get in the way of the flow. And give us a way of tracking things in a way that can be verified down the road and help things make, So that's what we're going for. And it's gonna take a long time, but if we don't start somewhere.
Olivier,
Yeah, two
Yeah,
quick questions.
Sure.
What is the process you expect when you want to change the code? You change the requirements first and then the code, or the opposite? And I will tell you why I'm asking.
You can do both.
Ideally, you're doing both at the same time. Realistically. We'll see both happen and we just need to be able to catch it. We need to catch it if someone changes the requirement, the code doesn't match, and we need to
And
change
you've
it.
got the hash mechanism to do
Right.
that.
I think
Probably
you-
you
the other
change the code, the CI frame, you will see
Yeah.
fail and you will probably.
Change that.
it can happen that you change the requirement because you realize that there was something missed in that requirement, right? Indeed, it cannot happen that you change a requirement. Basically, you cannot change code expectation before you change the code. So
That's it, isn't it? You've kind of inverted the relationship.
that's impossible, right? So I mean, it's like, if you want to add a feature, you don't push a requirement with the new feature without pushing the code, right? Yeah.
So that's something we will have to talk with some auditors. Because the goal of some
Good.
standard is to think before you change the code. And then you verify the code against your requirement after you.
Yeah, but we're in a brownfield right now. We're not in greenfield, so.
Exactly, so that's why I
I
was asking.
Yeah.
Because.
I think that in the end, I'm pretty sure everybody thinks before you change the code. It's just that you have to write it down.
It's just
Well, the thing is,
that-
you have to have a reason for the commit for it to be accepted.
Yeah.
And
But-
realistically, the reason is a change in a
So
requirement
the way
usually.
you present the process to the auditor will have an impact. In particular, in avionics, they make it clear that they don't want reverse engineering. But usually there are debates about the meaning of reverse engineering. So if you say in the process that when you want to change the code because you want to change the behavior, if you do both at the same time, it's like you change the requirement and the code.
Mhm.
And it
So-
goes through a review process
Yes. And
of the two together, and therefore it's.
but the way you present it to the auditor is going to be important.
Or it's important to have the right auditor.
Sorry.
Or it's important to have the right auditor in this. I mean, if there's also, you can achieve the same thing and even within authorities.
Yeah,
Maybe
there's a clear
various ways,
statement
but-
by the FAA that.
Yeah.
the
Okay,
way
no,
you
this
should
is
do
good.
it.
This is good
Yeah.
this is a good factor. I think I've caught it. No, it's.
And
Yeah.
when you said you should change both, that's fine. In fact, you need to.
No.
And quite frankly, you need to say this requirement was derived or accepted or some explanation in the metadata behind the systems.
Yeah.
So we should have the language for that. To be able to show the traceability and then hook to the commit.
Yeah.
And have the information traceable.
But
It
what-
should be possible. It's just a question of figuring out the tooling.
Yeah. I'm just thinking that if the code changes without the requirement change, the hash key changes, okay, that is a.
Yeah,
flag.
that's the HK changing from the original ID.
However, there is not. Today, we don't have like an explicit flag that says,
If the requirement text changes and the code, it's a new requirement, which has derived from the prior. You don't reuse the requirement ID if you change the text in the requirement.
Or you can do it in the same requirement, then you have to change the code.
But it's a new hash effectively,
The
because you've
hash is
changed
always
the
a new
hash,
one.
the ID part of the time. We've got the two mechanisms, right?
Yeah.
We've got the ID of it, the thing itself, which is a hash of the requirement. And then we've got the hash key, which is a hash of the code associated with that requirement.
No,
So we've got two hashes sitting there.
No,
No?
both requirement and the hash use the same mechanism.
Yeah, no, but they're over different parts of the.
No,
code. They're
are
different-
identical.
over different lines.
Both the same.
Identical.
So the hash will change if the requirement text changes or
Or,
the code changes.
Or the code
Yes.
change.
Or both.
That's correct. It tracks both.
that's both, okay.
What we're missing today is like I mean, a sort of a valid, invalid bit.
Well, I think, yeah, I think this was, we will continue this discussion in the architecture working group. Anyone who's interested can join us
Yes.
and
Yes.
participate.
Yes.
the second question, I think you almost answered. You were talking about breaking the requirement into sub-requirement. I guess to check which code applies to the requirement, you're going to move it next to the code.
Yeah.
Okay.
But
No,
that's not possible.
No, that's not what you're gonna
It's
do.
not what was suggested by Matteo, so
So
just
that-
give you the requirements
In
on
that,
top of the function and then you,
No,
Yeah,
the requirements must be only on top of the function.
not
so
inside the
in
function.
that case, how you detect that the code relating to this requirement change?
Yeah.
Yeah.
Because if you have the whole code of the routine,
They have a semantic relationship and that's it.
Yeah, there is not that level of granularity inside.
And realistically, if we need to go that level, we we encourage refactoring of the code into
Yeah.
our requirements
I mean, that
for
means,
functions, right?
So yeah, I think Olivier is identified part of the burden of maintenance here, which is actually it's.
Probably I created a bias.
Yeah.
yes,
which ways to the end is it worth it to break it into sub-requirement?
yeah, I mean, practically speaking, I don't think it's really needed, because look at this requirement, okay? So this is complex.
Yeah.
It's made of some requirements, but for example, if I use Basil, example, I can trace so each of these, so this guy will have one or more tests, and then this other guy will have one or more tests. With Basil, I could trace the test to the subsection of the requirement.
Yeah,
So-
so in the end, when you do the coverage analysis. how you
Exactly.
make the link with the source code.
There's still
You can.
question
go to the
about,
source code.
or
Oh, sorry.
comment.
Yeah,
Mhm.
I was thinking when talking about traceability and this hash that traces both the requirement and the source code. Probably we should even trace the object code, because in avionics you have to show that you don't have dev code, for example. And lots of work is invested in showing traceability between the assembler code to the C code back.
So for that angle, we can trace from the source code to the built image in SPDX, and we're doing that today, both in Yocto and in Zephyr. So we have the linkage there. What we're missing is now we'll have the linkage from the requirement in the source code to the source code files. So we will eventually have that full path down. But we'll use different tooling to get there, but it should hopefully eventually be all in the same knowledge graph.
So is this only intended to be used for compiled languages, because if you don't have object files?
Yeah.
What, so which one, like functional languages?
Just.
Give me an example.
Just like scripting,
Scripting language like Python or something like
Yeah.
that, right? Yeah, well, it's the lines of file. And it may not even be tokenized, you just take the source and you treat that as your executable effectively, which is what's happening there. And in fact, a lot of the package manager systems sort of work in that node. And they don't, but like, you have, sometimes like in Java, you have the precompiles, sometimes you tokenize things and things like that for optimization. So there's a variety of different mechanisms that need to be encompassed, but building linkage between the sources and the actual executables, there's ways of doing it.
But that requirement is the one like a one for the linker itself. but
Yeah,
you don't have
That's where, actually, that's where the knowledge really is, and that's why when you're seeing those life cycle, you generate those bombs where the knowledge really is. And that's exactly how it's happening in the CMake files in Zephyr. And it's happening in similar places through the debug information in Yocto. Because the information is well known at that point in time, rather than discovered by basically software code analysis tool, an SEA tool. So the recommendation is, as much as possible, we build this into our full build infrastructure. So this stuff is generated accurately.
Yeah.
And if it can't be, and you have to do an analysis, so be it, it's gonna happen. But if you can get it coming out, that's when we start to get the power of being able to be reasoning about this with efficiency and effectiveness in the CI flow, the CI/CD flows we're gonna need.
So another question.
Oh, yeah, I'll just switch there.
No, my question is about the relationship of these with tests. It seems that we deal with them separately, but it could make sense to think that since most of this is really tests in the end.
Yeah.
Why not evolve both things together?
That's,
So that
yes,
That's the
yes,
final
that's
goal.
exactly where we're
That's-
going.
That's the final goal.
And that's why we're talking to Kernel CI guys.
And in that case, some parts of the specification couldn't be just tests.
Right,
Because you're trying to write in English something that is directly
Testable.
written in the
So
test.
write it in test first.
Yeah, and it is a more concrete and more specific. And
Oh,
there is no, they are completely clear.
So, and another way to do that would be your instinct was to write in pseudocode. So if you wrote in pseudocode that was actually pseudocode that was interpretable test language.
Yeah.
Actually, maybe that would be better. So you've got an interpretable test language that describes the intent, or more importantly, describes how you verify the intent.
At this when that's easy, in some cases that may be very difficult, but in some cases that's easy. I mean, it should return 0, for instance. That's easy to write into a text. And it's completely unambiguous and you can read it and it's easy to, and even you can translate it into English if need.
But the problem is that today we have a gap. I mean, today we have the code and we have test code. And we don't know if the test, so.
But you're trying to bridge the gap
Yes.
with the
Yeah,
English
here-
interpretation
yes,
of the code.
yes.
And it would be
Yeah.
in the same commit, you should be changing the code, the specification and the test. And the order should
Yeah.
be just to.
Ideally,
obviously,
yes.
The order should
Completely
be,
agree.
first of all, reviewers look at the specification, second, they look at the tests, and third, they look at the implementation.
Yeah.
In
So
this order.
what you could do that would, building on what you've already got, is use this kind of the ID and the hashing mechanism that you're building into the code as a link to the test. And then you can compare the two together in CI and say, hang on, I don't have the test.
Or even in the same commit, so that you go to the commit and you see everything together.
Yep.
Right. The thing is that a lot of tests, there's multiple, as you see there's multiple test frameworks out there. So we need to link externally.
Yeah.
Right, our commits are within a code repo generally. You don't commit to other repos simultaneously. So we need that hook to connect everything.
I guess, I mean, what's also important to see here, even if the requirement text does not change and the source code does not change, doesn't mean that the requirement will not change. I mean, here comes the testing, because if you have the set of description plus source code, and the source code calls a function, we're like in the very early state. If this function underneath change behavior or anything, then your
test
requirement
change.
is affected. And this is something which you most likely will identify with the test case. Unless a test case which check the requirement is still passing, then it also most likely can create the assumption, okay, then it's the change, whatever the function has done is not affecting it because it's like an error check or whatever. But we are in a 0 point nothing world where not a single requirement is in there, but the first requirement which you write in here already makes function calls. And if these functions then it needs to change, so that's just, I mean, the point here that we want to bring is like, this is not something where you can trust, and just because the code has not changed, the requirement has not changed, it doesn't mean that nothing changed in this area. It's always the test case needed, and you need to bring them
Yeah.
together then.
Yeah.
And yeah, I agree.
Another point that I say, so it's if you just use a test case to describe the function, you cannot have an idea if the set of tests you have is enough or not. So you don't have the
No,
full list of
No,
expectations.
maybe I was not clear. You still need the specification, but some
Okay.
of the details in the specification could be written as tests instead of English.
You know, okay, now.
A part of it, another part, of course, you still need a part of the specification. Everything that is more complex to write text for or to understand, or even to understand the test. Some tests could be really difficult to
Yeah,
understand.
there's
So
also
maybe you need
a format, nowadays a framework like Pragmacy or stuff like that. That's kind of human language spoken format to write. tests.
And like I say, these are the things that will probably have a lot of feedback from the kernel maintainers as to what exact level they want. Like, I think one maintainer will want it one way, another maintainer will want it another way. I think we're gonna need to figure out and socially engineer, like basically work with, trying to figure out what the reasonable consensus is
Yeah.
going to be for this community
And
and
you,
then document it.
and you need to also, when you bring this into the kernel, even if it's just a small part, it's there and it's a chance for others to write their specifications. And like we're talking about integrators, distributors and others, there's a chance to just use this mechanism, bring it in, and then decide on your own if you want to bring this into the kernel. And hopefully people will write the requirements there because they see the use of it and the need, and then exactly figure out what you figure out, like touching two function and finding two issues, more or less, right?
Mhm.
Or it's only like 4 or 5, whatever.
Yeah.
You found like issues directly, you can say like what's the impact of the issue. It depends on where you are and which environment, right?
Yeah.
And so you find these, you simplify parts, and this can really bring then people committing, and then you get also more visibility. It's like, oh, why are these people doing? Oh, there's functional safety involved or whatever, and then
Or
also
using-
kernel make get visibility because a great bunch of them may not be aware that their parts are considered to be in critical environments. So more like a huge set of the Zephyr people mainly working in IoT and not having a direct focus on the safety certification activity there or safety enablement, I would say, right? That's just like the environment where awareness can be created just through these kind of mechanisms.
Yeah.
But for the case like the crypto API.
Right.
Crypto guys might not know.
Right, where it's
right?
being used.
Just might not be aware.
Yeah.
Right, and oh,
Surprise. But yeah, I think, focusing on the parts that are used for everything initially, getting some common understanding of the level to document it.
Yeah.
Greg has also volunteered up some of his subsystems for us to pilot in as well. And that are much simpler than this tracing one.
Yeah.
Just to show it easier for other developers to see. But there's a recognition that there's a lot of technical debt at this point in time in the kernel. There are areas where no developer wants to touch it because there isn't adequate maintainers. And so by doing some of these exercises, I think we will improve the quality of the kernel and make it more sustainable, which will appeal to a lot of the kernel community. So we're working on making sure that they see a value for quality and the technical debt, because we've got senior maintainers who are about to retire, okay? If not retired, and then there's some that are just no longer around anymore. So how do we make sure that the kernel stays relevant and can be updated and kept forward? And if we have these things in the human readable form, we've got the linkage to the testing, well then, hey, when someone really feels passionate about changing a subsystem over to Rust,
They can do it.
they've got their test infrastructure, they've got their requirements documented. So we make it, and when, someone's coming in fresh and has to go tackle something, well, if the requirements have been documented, they know what they can test, they know if they're done. Or not, So we've got, it's giving us a tool for improving the sustainability of the kernel. So yes, it's a big lift, but it will also help us on the safety side tremendously too.
I mean, this is something that cannot be achieved by a single person. But
It'll take an army, but
yeah,
if an army needs a battle plan, then this is a battle plan.
Right.
I say that made my head explode, but I think you've got something really
Yeah.
interesting here.
Okay, I think what you said, it is good to start by the maintainer feedback of what they want to do.
Oh, yeah,
And the exercise we can do on the side without telling him first is, let's do the activity that the standard required, like doing a code review against the requirement, doing a test review against the requirement, to see if the way the requirements are writing, like
it's
that
going to work.
it fits.
Yeah.
Yeah.
See what works.
So basically now, okay, now as part of the lesson learned, right? So the third point is that in order to get the requirements framework accepted upstream, it is better to show the value first. And for this reason, we are prioritizing the documentation of testable expectations over completing the requirements framework. So basically now, the idea here is to forget about the SPDX format and basically just start pushing, for the time being,
Show value.
just
Yeah.
pushing just
Yeah.
pushing, you know, the
Looking
semantics.
innocent.
No, we're not looking innocent, we're basically trying to improve the documentation and understanding of the kernel.
Exactly,
It's
because
nothing innocent, it's value.
yeah, exactly. Then after we show the value, we can say, hey, but we
And
have,
now you
we have
can
a,
adjust.
exactly.
And now if you
Yeah.
put this in, do all these things.
Exactly. You know, we have a way to maintain these.
And we have a way to link to the tests,
Exactly, and to link to the test.
to be more efficient about the testing.
Yeah.
Which is the part of working with Gustavo and their YAML files, etc.
Because there is case that tomorrow I go to the mailing list and I present this table. And I get a middle finger back. Because like, what? You want me to feel this?
Yeah,
For
exactly.
what?
If you show them that, they're like, they're out.
Exactly.
No, they will, like I
You show them
say,
the
some of
comments.
them. No, gave us that task. They will not give us a middle finger.
No, but.
But the wider community needs to see a value before we introduce this.
Exactly.
Have you shown this to Pete?
No, I actually haven't talked this one through with Pete.
I think he'd love it, but
Well, like I say, let's start getting the,
he's not the
Yeah,
target
comments.
audience. Maybe he is part of the target audience.
well, he's part of the target audience and he'll be happy to see this stuff. I don't think he's gonna, you know. We can talk, like I say, I'm completely comfortable having a side discussion in one of the meetings with Pete and making sure that he doesn't see any flaws. But I think the ones we have to convince are the kernel community maintainers. At this point.
Yeah.
Have you guys considered like, Paul, you had that comment about, we just translating the code into English.
I know what you're gonna say.
And, but, you have some people, I don't know, hopefully, anyway, but you have some people that strongly believe in self-documenting code. So in this particular example, we had this really long, complex function. Rather than, trying to document the function and stumble upon, a bug, which is commendable. Maybe another approach is to actually simplify, break up the function so that it's more manageable. And then, and then, this self-documenting code, realization actually could happen and then, I mean, it's just a different way of thinking about things. I'm not saying that we're doing it wrong.
I think we will see the refactoring happening in some of these subsystems automatically by the maintainers themselves, once they start seeing what's happening.
Once they look at the code, they'll go,
Yeah, but I have a very strong opinion about self-documenting code and all this, the truth is in the code thingy. If that would have been the truth, we wouldn't have had planes falling from the sky. Because there was no intention for that. There is no intention for cars accelerating without being able to brake. There is no intention for this behavior, but the behavior is exactly what was in the code. So.
So the thing is, there is a, this does hit on a hard thing, isn't it? Is the purpose of computer languages is not just to communicate with machines and computers. It is to communicate with other humans. If the language is not doing that effectively, then it's not serving one of its purposes. But that doesn't mean that the intent of the code is visible. So the code documents the kind of what the code is actually trying to achieve, but the intent behind that is what's missing. And that's the bit that I would like to see in this is what is the purpose of this function? Not what each of the steps do, but what's the overall intent and how is that potentially affected by these different.
So let's get the low levels cleaned up and then we should be able to factor into the higher level.
Oh, yeah,
So we want to
definitely.
surface
Yes.
up to a wider system.
That's why I don't know if anyone saw the talk about applying from a C to the kernel. That's absolutely fascinating. It's well worth looking at the paper that's available online about it, which is kind of breaking the code down into logical steps and then having it documented as a header such that you can automatically generate tests for it because it's broken down into logical steps. But it is a non-trivial exercise to do that thinking, do that reasoning about it.
Okay. So last slide. So the next steps. So as I already said, first thing to do is to push the text section, so the code expectation upstream to show the value of documenting the kernel code. And then we should present the requirements work at Open Source Summit North America. In Denver, and then we should bring more maintainers, actually along with us as any, bring more maintainers and respective subsystems on board. So let's see, and also recruit more people and keep working on requirements, pilots and automation. And actually, if any of you who likes reverse engineering the code,
Who would like to learn more about the Linux kernel?
who would like, yeah, who would like to, you know, to try sending some patches upstream or
private laptop.
huh?
Yeah.
Any volunteer? But anyway, if there is any volunteer, you know, please join the safety architecture working group meetings. And we meet on Friday, 4 to 5 p.m. Central European Summertime.
Mhm.
So. And yeah, so the last step is to discuss at Linux plumbers.
And actually, I'd say the step after that is, I think we're getting close. We might try to see if we can get it into the maintainer track discussions.
Yeah.
Okay, which is happening around the same time as plumbers, but that's a judgment call if it's this year or the following. year.
Let's see, yeah, that's,
Okay, because that's where the decision will be made to say, yes, we will go, and there'll be enough maintainers lined up at that point, we can get it. But this is a social engineering problem, okay? And that's most of the kernel problems these days, are social engineering problems,
It's showing the way.
showing it.
Pointing the direction. Actually, if people pick up on this and say, actually, no, I'd rather do it like this.
Fine, we adapt, as long as they've come up to consensus. It's like, for instance, the initial SPDX IDs, for instance. We had them as, you know, star comments and we just went, no, we want // for these. Okay, fine, whatever. Yeah.
Yeah.
As long as they're adopting it, and we can parse it, that's what we need to find, we need something we can parse. Okay.
okay, I think I'm done, we are done.
So